We're good to go. It's counting.
Okay. All right. So what are we learning about in class?
Faults and earthquakes, weather and climate.
Good. Why is it important for us to learn about earthquakes?
So we can know what's going on, where to move to and stay, and where not to move. The good places, bad places.
Good job.
As far as safety.
April 18, 1906, California's San Andreas Fault snaps, shaking San Francisco for nearly 60 terrifying seconds. When the trembling stops, the disaster is only beginning. Gas lines rupture, setting off massive fires. Some 700 people died. Most of the city was reduced to ruins. This trembling of the ground, caused when masses of rock suddenly shift below the Earth's surface, is called an earthquake. Hundreds of little earthquakes shake the planet every day, but most pass unnoticed. They usually occur along the boundaries of the thin plates that cover the Earth like an eggshell. Driven by the heat deep within the Earth's core, the plates grind against each other along lines called faults. When the plate's motion is blocked, stress builds up.
I see what you're saying
Fault
now.
gives way. The released energy races through the Earth in the form of seismic waves. Scientists record these waves on a device called a seismograph. These zigzag lines show the strength of various seismic waves. Using the lines, scientists grade earthquakes on the Richter scale. For a quake to measure one number higher on the Richter scale, it must release about 30 times as much energy as the number below it. Every year, about 100,000 earthquakes rumble through the ground hard enough for people to feel them. Of these, only about 1,000 are strong enough to damage property.
I think you can
But a
just
powerful earthquake can be devastating. On average, about 10,000 people die each year as a result of earthquakes. The greatest recorded earthquake ever to hit North America measured a massive 9.2. The tremor struck Alaska on March 28, 1964. A camera on board a ship docked in Valdez recorded the draining of the entire harbor as a chasm opened up on the sea floor. There's no stopping the surface of the Earth from changing and moving, so engineers are focusing on ways to create better buildings, highways, and bridges, structures that will remain safe and stay in one piece the next time the Earth begins to shake.
Okay, so what are faults?
Fractures,
Along which
the movement
occur.
slips or occurs.
Very good. So what do earthquakes refer to?
Ground shaking.
Good. All right. What are we looking at right here? Think about it. It's where the most damage is. It's where we feel the earthquake.
The epicenter.
Good. Okay, so the focus is where the earthquake happens. All right, so that's going to occur under the ground. And then the epicenter is directly above the focus. So that's where we feel it. The focus is where the earthquake occurs. So again, The point on the surface that lies directly above the focus.
Epicenter.
Good. Okay, so what refers to the exact location along a fault where rupture and slip occurs?
Focus.
Excellent. Okay. Hanging wall versus foot wall. The hanging wall is going to be above a fault plane. The foot wall is going to be below the fault plane. Another way to figure it out is by the angle. The hanging wall's angle is smaller than the foot wall's angle. Okay, so where do you think the fault line is? Or fault plane?
In the middle, between it.
Yeah, this is the fault plane. Okay, where has the earthquake occurred? Where's the focus?
On the fault plane.
Good, right here.
Okay.
Which means the epicenter is going to be
Above.
the focus, up here.
Okay.
You good?
Got it.
So, either the foot wall or the hanging wall, which is the one that moves? Do you ever see the foot wall move, or does it stay in place?
Stays.
Good, which means the
Hanging wall.
is the one that moves. Okay, so we're looking at these yellow lines. What do you think we're looking at?
Earthquake, where it's like, well, the hanging wall, foot wall, split.
Yeah. Think of it kind of like as a scar of the earthquake. It's the fault scarp.
Oh yeah.
All right. Now I am tracing my finger along this. What is this?
The fault trace.
Good. All right, let's start with the easy one. Again, foot wall versus hanging wall.
Foot wall has a bigger angle and
Good. So this is the one with the bigger angle. So here's your hanging wall and your foot wall. We've already determined that this is the fault plane. Okay. What do you think this one is?
the fault trace.
Close. What's the other one we just
Oh,
discussed?
fault scarp.
Good. And so the other yellow arrow?
Fault trace.
Good. So the fault scarp is going to be above the fault trace. So an intersection between the fault and the ground surface, also referred to as the fault line.
Fault trace.
Very good. So when an active fault produces vertical offset of the ground surface.
Fault scrape.
Scar. Good.
Scar, yeah. Sorry.
And this is just a cute little picture that I found. See, the cat's the hanging wall,
Yeah.
and then the box is the foot wall. Hey, what boundary?
No.
Transform is this way.
Convergent.
Convergence this way.
Oh, divergent.
Good.
Yeah, finally I got it.
Cat thing.
Okay, let's practice some more with hanging wall versus foot wall. So, which one has the bigger angle?
On the left. Well, yeah, the foot wall.
Yeah, the foot wall. And then the hanging wall. Oops. Okay. Again, which one's the hanging wall and which one's the foot wall?
Foot wall is the bigger angle.
Okay, what side?
Right. Is it on the right side or the left? This time. I gotta see.
That angle?
Yeah.
Yeah.
Okay.
This is the smaller angle, this is the bigger angle. Again,
Hanging wall on the right, foot wall on the left.
what we're looking at is the fault trace.
Where's this from?
Canterbury.
England? Or I mean New Zealand?
Yeah.
That's awesome.
Okay, now we're looking at a fault. What are our two faults?
The trace and the scar. Or
Okay, that's what happens because of the faults. We have two main faults.
dip slip,
And,
strike slip.
okay, does this fault look like it's sloped at an angle? Does it look sloped at all?
No.
Okay, so that means it's not dip slip. So strike slip, the faults, they slide.
Okay.
So You can see the fault line by the white chalk. So this is the strike slip fault. Note, dip slip faults slope at an angle. You have your reverse, your thrust, and your normal. There are 3 types of dip slip faults. Here is your hanging wall. How is it moved for normal?
Down.
Good. Here's your hanging wall for thrust. How is it moved?
Up.
Good. What about reverse?
Up.
Good. So note, the hanging wall for normal fault moves down. For thrust and reverse, it moves up. So here's your foot wall, here's the fault line, and here's your hanging wall. What fault is this?
Normal.
Why?
Because the hanging wall has dropped down.
Good. Then here's your thrust, and there's your reverse. These are going to go very fast, but these will show you how they move. There's your fault line, and that was your strike slip fault. Do you need to see it again, or are you good?
I'm good.
If you need to see any of these again, just let me know. Here's your normal fault. Again, the hanging wall is moved down. There's your fault line. And they slope at an angle, the dip slip faults. And here's your reverse. The hanging wall is moved up. This is a thrust fault. Sorry, it squeaks really bad. But I think actually they go up too far.
Yeah, and they should have just pushed it up the ramp.
Yeah.
It's not realistic. Yeah, that's
Yeah.
not realistic at all.
Yeah, that looks more like reverse to me.
And just, oh, you know what? That's in a museum. That's somebody filming it in a museum.
Okay.
Yeah, the museum people should have done a better job building that.
Yeah. Okay. What is the first thing you notice about this fault?
It's split.
Hanging wall versus foot wall. Does it have one?
No.
Good.
Yeah.
So now we automatically know it cannot be a dip slip fault.
Okay.
So what fault does it have to be?
Strike slip.
Good, because only strike slips do not have a hanging wall or a foot wall. Okay. So, how would you describe this fault plane?
Vertical.
Good. What type of offset should it not have?
Horizontal.
Lateral.
Lateral.
It does have lateral offset, but it does not have vertical offset.
Okay.
Okay. What type type of boundary is it? Like I said, this fault slides past it.
Divergent.
Sliding past.
Oh, yes.
Divergent, they break away. This
Oh,
boundary,
slide. Convergent.
convergent, they come together.
Transform.
Thank you, transform
Sorry.
boundaries. Now, when you see strike slip, automatically think California. Where are we
Yeah.
gonna find it?
Oh, Hollister. California.
Good, but what's the fault line? A famous fault line in California.
I don't remember. California. Oh, San Andreas.
Awesome.
Oh, yeah, I had to really think.
Okay, actually I put up two examples.
Okay.
The San Andreas fault and the North Anatolian fault.
Okay.
But you just need to know the San Andreas fault.
Yeah, I can remember that one.
Okay, in order to decide which fault, or which fault this is, we know it slips at an angle, so we know it's tip slip.
Okay.
How is the hanging wall moved?
Drop down.
Good, so which fault has the hanging wall that drops down?
The normal fault.
Good, so this is a normal fault. Hanging wall, footwall. All right. What are these arrows doing?
Showing the divergent boundaries.
Good, divergent boundaries because they're drifting apart. Also, the angle does not matter. Where do we find divergent boundaries?
The mid-ocean ridge
And
continental ridge.
rift zones.
Rift.
Good. And the hanging wall drops down in relation to the footwall. And also, we're going to have extension and stretching. Are you good on this? Do you need to copy it?
I'm good.
All right. How is the hanging wall moved?
Down.
Which one's the hanging wall?
On the bottom? Or is it? Those are kind of close. It's hard to
Okay.
see. Yeah, I need my angles.
Here is that angle. And here's that angle.
Oh. Up.
Right. So, that means normal fault is out.
Mm-hmm.
So it's either going to be one of two faults, which are
Thrust or reverse.
good. Thrust and reverse are exactly the same thing. The only difference between a thrust and reverse is this angle.
Okay.
If it is if it's less than 45 degrees, it is thrust. If it is 45 degrees or greater,
Mm-hmm.
it is reverse. So here's the angle. What is it?
Thrust.
Good. Okay, what are these yellow arrows doing?
Coming.
Together, which makes it a
Convergent.
good, a convergent boundary. So you're also going to have compression and squeezing. Where do we find convergent boundaries?
Was it Mid-Atlantic? No.
The Mid-Atlantic Ridge might be a divergent boundary.
Oh.
We're talking about convergent boundaries. What are our two crust types?
Ocean. No.
Yes,
Ocean.
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 Uh-huh.
And ocean, the continent.
Uh-huh. And
And
then
then continent to continent.
Awesome.